will proceed in innovative approach in calculus and cross Jacobian where we have our invention is that place we will see. Okay, but still it is thinning. I believe it is little bit dark out here. For 3 days it is continuously raining here. So rain is not very harsh, it is mild only, but there is no sun for continuous 3 days. Okay, anyway, that is the scenario out here. Now we are in discussion. We are in discussion for the innovative approach in cross Jacobian. Prior to that, sensational directional derivative along a line or along a vector. So, as always, I have said that as always, we see that in mathematics, the reality 99% of the mathematics sits upon numerical science only. If we are not able to solve something through numerical science, it is very complex, then we go for algebra. If it is not solvable in algebra x, y, z, then we go for different coordinate system in algebra. Still it is difficult, then we try to use the integration. Still not solvable in algebraic fashion, then we go for vector or algebraic vector field. If someone has higher level to it, then he can think about it. But this is how the hierarchy is. So what in mathematics, what we expect, like if we make a friendship, we go along with someone, internally we expect kind of good heartness, or indirect way we expect love from him or whatever. So in that way, if someone is proceeding in mathematics, at the end we expect addition. So mathematics is nothing but at the core it is addition. So to get the addition, we have subtraction, multiplication, and division. But the net idea is addition. And then algebra, different coordinate system, integration, vector field. Like directional derivative along x-axis, that is dy by dx, or if it is three-dimensional, dz by dx, derivative along y-axis, dz by dy, derivative along any axis. So x-axis, any axis, alpha. This is x-axis, this is y-axis, and this is z-axis. X-axis, y-axis, z-axis. Now dz by dx, this is xz plane. This is yz plane. If this is xz plane, then dz by dx, dz by dy. If there is a alpha line, this is x line, this is y line, in between there is a alpha line, dz by d alpha. If I go along alpha unit distance, how much how much change in z we see, that is dz by d alpha. That is directional derivative along any axis alpha, which is not x, which is not y, or x and y can be a special case for that generic way. Then it is not solvable. Why it is not solvable? X-axis is y equal to 0. Y-axis is x equal to 0, the algebraic equation of the line. If I have a alpha, then its algebraic equation can be x minus y equal to 0. dz by dy equal to 0 is dz by dx. dz by dx equal to 0 is dz by dy. dz by d alpha is nothing but dz by dx minus y equal to 0. That is not solvable in algebra. Then we go to for rescue to vector, and in vector there we get the vector form of this line, that is x minus y equal to 0, that is I plus j. Since the, in vector form, if you see, then x-axis is I vector, unit vector, y-axis is j vector, unit vector, dz by di vector, dz by dj vector, dz by di plus j divided by square root of 2, that is the unit vector along I plus j vector. I plus j is a one vector along which I want differentiation for the z, dz by d alpha line, dz by dx minus y equal to 0 line, or dz by d I plus j divided by square root of 2. Now it is a unit vector. Okay, if it is very pretty simple in vector talks about the components. Vector is nothing but addition of orthogonal components. That's it. If I want anything in any direction, get the thing in x component, get the thing in y component, and then simply add it. Like if I say I have a vector I plus j, that is nothing but combination of two vectors, I vector and j vector. That is I plus j. Okay, it's not one thing. It is combination of two vectors, I and j. Then it is I plus j. I plus j vector. If I plus j vector, if I see, if I take it's a kind of ith component, x component, then it is I. If I take yth component, then it is j. Okay, so I want to calculate directional derivative of z along a vector I plus j. But when we go for directional derivative, we consider unit vector like I is unit vector, j is unit vector. I plus j means I plus j divided by square root of 2. So dz by di, dz by dj, that is I x axis and y axis here, dz by I plus j divided by square root of 2. Now, as I have already explained it, so consider I have a 3D. I really have a 3D. Okay, mind blowing. Okay, so can I try eating it rather than demonstrating it? Most delicious one. Okay, anyway, now the question arises is what is the directional derivative for this? This is 3D. This is 3D and this is xy plane. This is x-axis, this is y-axis. Now in that case, if I see this, consider this is a kind of parabola. I mean paraboloid. It is really a paraboloid, right? And this is this way. This is really a paraboloid. Can you see? It is really a paraboloid. So someone has said, or someone had communicated to the tree that please give me a paraboloid. And tree made a paraboloid and just dropped it. Okay, so it is far better than going to any paraboloid industry. Now, if that is the case, if this is a paraboloid, then now I can take contour. I cut it here at height 1. I cut it here at height 4. This is what example I give. If I cut it at height 1, then it is a circle. That circle I can draw on xy plane. Simple circle. If I cut it at height 4, again there is a bigger circle. Okay, that is z contour. So on xy plane centered at the origin, I can draw a circle with radius 1. I mean the equation of this paraboloid is z equal to x square plus y square centered at the origin. Means this tip is kept on the xy plane at the origin. So if that is the case, then the circle, then at height 1, 1 equal to x square plus y square. X square plus y square equal to 1 is a circle. X square plus y square, if I cut it at 4 equal to 4, 2 square. Again it is circle of radius 2. I'm repeating this third video. But this is something that is thrilling because if someone understands this vector concept, then he can crack anything. Vector is something that is highly crackable. Why vector is so precious? Because vector can contain algebra. That is called vector field. A vector can contain a algebra. That is one thing. And second thing is vector has a direction. Algebra does not have a direction. Vector has a direction. So that's why it is higher level. It has many things. Now in that case, now consider this is xy plane and then this is a circle. Up. Okay, so now this is xy plane and this is x-axis. This is y-axis and this is alpha axis. Any axis alpha. Okay, now I take it out and now this is x-axis and this is y-axis, and this is x-axis. Now, I cut the paraboloid at height 1. If I cut the paraboloid at height 1, then there is a small circle. X square plus y square equal to z is the paraboloid equation. Then x square plus y square equal to 1. Now, there is a small circle in at the center in xy plane. If there is a small circle at the center, this is x-axis. This is x-axis. Okay. Now from x-axis, if I see this circle, if I go to next contour, that is of radius 2, this circle would start increasing and slowly it will become of radius 2. Okay. Now from x-axis, if this is the kind of x-axis, then person from x-axis is seeing in this direction. The change it is making, the contour it is changing, right? If I take both contour from a contour that is x square plus y square equal to 1 and another contour is x square plus y square equal to 4, then this would change. Okay, from x square plus radius 1 to radius 2, it will start growing. The contour will start growing. From x-axis, someone will see in this direction, up direction, where it is seeing the change. In y, from y-axis, someone would see in this direction, when he is seeing the change. From alpha axis, he is seeing in this direction. Okay, direction is different. Okay, this direction, if I alpha axis, if I make x-axis, he is seeing like this. Okay, alpha axis, if I make y-axis, he is seeing like this. Okay, from alpha axis, he is seeing like this. Or someone would say, he is seeing like this, whatever it is, perpendicular to it, perpendicular to it. So this is how from alpha axis he is saying. So if circle is here, if circle is here from x-axis he is seeing like this. The farmost point he is seeing this tip. From y-axis, the farmost point he is seeing this tip. From any alpha axis furthermost point, if he is seeing, then he is seeing this tip. X-axis this tip, y-axis this tip, from alpha axis this tip. This is the direction. Now the idea is how much dz by dx, how much this contour is changing. This contour is changing from radius 1 to radius 2. How much this change is seen from the alpha axis. This change that is seen from the alpha axis is nothing but change that is seen from the x-axis plus change that is seen from the y-axis as per the vector fundamental. Vector fundamental is nothing but whatever we see from the x-axis, whatever we see from the y-axis, just add it. This is what is the net result. Or if I take in 3D, then this is paraboloid. This is paraboloid, then this is x-axis. This is y-axis. This is z-axis. If that is the case, then at any point, if I cut this paraboloid, if I cut in xz plane, this is yz plane. If I cut in xz plane, then at any moment, if I calculate dz by dx, then this is the slope in xz plane. If I calculate dz by dy, then it is this slope in yz plane. If that is the case, if this is alpha, this is x-axis, this is alpha axis, this is y-axis. We are trying to calculate dz by d alpha, directional derivative along a new axis alpha. In that sense, I cut it in z alpha plane. In z alpha plane, this is xz plane, yz plane, z alpha plane. In z alpha plane, then if I calculate dz by d alpha, then diagonally this way, this will is dz by d alpha, where this is dz by dx, where this is dz by dy. Okay, if that is the case, then dz by dx, if I am calculating dz by d alpha, then what if I represent alpha in vector form? Then what is the vector strength of alpha along x-axis? What is the vector strength of alpha along y-axis? Now, whatever the vector strength of alpha is along x-axis, with that strength, calculate dz by dx. Whatever the vector strength of alpha along y-axis, calculate dz by dy. Now add it. Then this is what someone would see the change from alpha axis that is dz by d alpha. Or if I talk in contour, if I talk on contour, because I have taken two contours, then if this is x-axis, this is y-axis, this is alpha axis. From alpha axis, if contour is growing from radius 1 to radius 2, how much change he is seeing from this alpha? The change that he is seeing in the contour, that change has x component, that change has y component. Calculate that x component change and calculate the y component change. If you add it, that change will be with respect to this vector. Okay, understandable. Or someone can understand this, that what we are trying to do, if this is vector or axis, and this is the change we want to see in the contour, just rotate it along x-axis. Bend this alpha along x-axis. Now see the change. Okay, now bend it along y-axis and then see the change. Okay, add it as per the vector fundamental. Now question arises is, how much is the change that we see? Meaningful, right? This is the vector. What meaningful? Someone, this is the vector. So if I say I plus j, then this vector has same component in I vector and j vector. Consider it is I plus 2j. If this is x-axis, this is y-axis, I plus j will make 45 degrees. I plus 2j will be like this toward j-axis. Now from here, if I calculate dz by d alpha, in this case, then dz by dy, yth component, okay, yth component will be higher because it is near j. So it will be dz by dy will be higher. So whatever change we are seeing, if I move this change in this direction, whatever change we are seeing along this, that change, the change will be in this perpendicular to this axis. If this is the alpha, change will be perpendicular to the alpha as we are seeing. This change what we are seeing, it will be more steep along y direction, less will be in x direction because vector is I plus 2j. Okay, now it is quite clear. If that is the case, then if this is the vector along which we want the directional derivative, what is its component along I-axis? First calculate the unit vector, because derivative in vector form happens through unit vector. So if it is I plus j, if I plus 2j, if it is I plus 2j, then unit vector is I plus 2j divided by square root of 5. Now this vector's component along x-axis is I by square root of 5. This component along y-axis is 2 by square root of 5j, I by square root of 2, and there j 2j square root of 5, I by square root of 5, and there 2j square root of 5. That is the component of this and this. Now with this I component, calculate the dz by dx or dz by di. So dz by, instead of dz by di, we are doing dz by di by square root of 5. So whatever dz by dx comes, we have to multiply by 1 by square root of 5 because it is becoming smaller. Here it is I plus 2j, I plus 2j by square root of 5, whatever it is. Okay, if it comes along x-axis, then it is the component is I by square root of 5, that much only. So differentiation will be smaller. Here again differentiation will be smaller, that we need to add it. This will be in direction. Directional derivative along a vector, not the derivative, direction. So along that, what would be derivative? So along which I have to go with the unit vector. So it is dz by dx into 1 by a square root of 5, that is x component, plus dz by dy into 2 by a square root of 5, that is j component. Just add it, and that is the directional derivative along any axis. Now anyone can imagine it is same as dz by dxi plus dz by dyj, that is called gradient vector. Dot product unit vector of the alpha axis vector. Simple. Or simply get the x-axis. If someone understands this vector concept, then he can crack cross Jacobian also. Actually, the idea is to talk about cross Jacobian. But what is vector? That someone must understand. Doing computation on any vector is same as doing computation on the x component of that vector, then doing computation of the y component of that vector. If it's 3D, then doing computation along z vector of that vector, and simply add it. Okay, this is the vector technology. Now in that sense, what is cross Jacobian? Now, how we can calculate surface area of this shape? What is surface area of this shape? Okay, so we were calculating surface area of a sphere, if I remember. So whatever, what is the surface? So calculating the surface area, again we need vector. Means this is high technology. How we can calculate surface area of any 3D shape? To calculate the surface area of any 3D shape, we need vector. With algebra, it is not possible. In that sense, if I want, consider this is a sphere. Oh my God, this is a sphere. This is a paraboloid. Consider this is a sphere. If this is a sphere, then how I can calculate surface area of this sphere? Okay, what about surface area at this point? Surface area at this point. Surface area at this point. This is algebra. Depending upon if this is xy plane, then any point can be represented as x comma y comma z, where z is function over x and y. X comma y comma function over x comma y is that point. If that is the case, then what is the tangent vector at that point? If I get tangent vector, that is along the surface. Can you see it? Here tangent vector is like this. Tangent vector is along the surface. If I calculate tangent vector at this point, okay, if I calculate tangent vector at this point, then if I calculate tangent vector at this point along x-axis, and if I calculate tangent vector of along y-axis, I mean, if this is a, I mean, other one will be better. Okay, this is bigger one. So now we are trying to calculate the surface area. This is sphere. Okay, so I communicated to the plant that I need a sphere, and it grew a sphere for me. Now this is a sphere. If this is a sphere, then what is the surface area of the sphere? Surface area at any moment, what is the surface area? What is the surface area of this surface? If I get this x-axis vector, and if I get y-axis vector, x-axis vector, y-axis vector, if I calculate the cross product of it, then this is the surface area. Can you tell me? Don't just give the logic. Can you prove it? I can prove it. So what is the vector of x-axis? 3i. 3i means a vector is in I direction and it has magnitude of 3. And in y direction the vector is 5i. 3i 5 sorry 5j. What is the area of this rectangle? So one has a vector of strength 3, one has vector of strength 5. What is the cross product of 3i into y 5j? That will be 3 into 5 k. Okay, k. So 15. 15 is the area. Very funny, right? Means calculating the area between any two vector is nothing but cross product of these two vectors. I, j, I and j. Take calculate the determinant or something like that, and it will be in k direction. So I, j and k. So from k calculate the determinant, and that will be something like the net cross product. So cross product of 3i into 5j is 15k. It will be in k direction. That is the area. So if I have any vector, okay, if I am talking like that, then what is the area between a vector I plus j and I plus 2j? Anyone would ask. Okay, I plus j, this is I plus j vector, 45 degree, and I plus 2j. Then this makes a parallelogram. Indirectly, we will calculate the area between a parallelogram. If this is the vector, if this is the vector, and this is another, if this is the vector, if this is the vector, this is another vector, we are trying to calculate the area. Indirectly, we will, this is parallel to this and this is parallel. It will make a parallelogram. Indirectly, we will calculate the parallelogram. In last case, I vector and j vector, this became a rectangle. So cross product does not mind it is rectangle or whatever. It will calculate the area of parallelogram only. So I plus j cross I plus 2j. This will give the area. So I cross I is 0. I cross j is 2k. 2k. Now j cross I, j j cross I is minus k. 2k minus k, j 0, k, k, 1k. 1 is the area between I plus j vector and I plus 2j vector. Okay, I hope I have done correctly or you can do it. So that is the area. So area between any two vector, if I calculate then that is the area. Now the way algebra works and vector algebra works, if I want to calculate the area, surface area of this sphere, that at any moment I have to calculate the two side vector. One vector is in xz plane and another vector in yz plane. Okay, so at any moment, okay, xz plane will give a kind of tangential vector like this in xz plane. Yz plane will give tangential vector like this. So at any point in the surface, if I calculate the in xz plane, whatever is the vector, and yz plane whatever is the vector, if I calculate the cross product of it, then it will give momentarily, because it's algebra at the end, right? Momentarily, what is the surface area? If I integrate it over the full surface, it will give me the net surface area. There are many analogy of this. Is one of the logic I am telling. There can be many logic of it. So all logic we will talk. Because if someone understands the vector, that is the pioneer thing he is understanding. Vector calculus, vector algebra calculus, vector field calculus, the most pioneer thing. Here, the artificial intelligence starts. Artificial intelligence, what is the machine learning data set we will see? I have so many features. Against all features, I have set of data that is called document. Each document has feature value. Each feature value is component. Each feature is called component like X, Y, Z. Now, one document, one data set against each feature is nothing but a vector only. Vector has component value, it has feature value. Rather than feature, someone can actually say component 1, component 2, component 3, not feature 1, feature 2, feature 3. Component 1, component 2, component 3, component 4, like that. So if I want data, what is its value against each component? If component 1, I describe it as I, J, K, alpha, beta, gamma, 6 components are there, then one data will be 1I plus 3J minus 5K, 16 alpha, like that. So it's a document vector, it is called. Now, if I want to see the change in the vector or whatever, then we can do the calculus like this only. Okay, this is the most pioneer thing. Now we have to understand that. Now calculating the surface, if I just know that if I calculate the dz, that the vector, surface vector along x-axis, surface vector along y-axis, then if I do the cross product, it will give me surface at that moment. Then I have to integrate fully. But we will see more on it. This is not satisfactory, right? This much. But anyway, this is the modern way of calculating the surface area. Old way also, we will see calculating the surface area, primitive calculus. We have talked about it in the last video. We are revisiting it because vector is very pioneer. In that sense, now consider any point on the surface P, any point in the surface P, and this is the center. From center, like if I have this centered at the origin, from origin, if there is any point P from origin, I can draw a vector like this. From origin, a vector is coming out like this. This point has a coordinate x comma y comma z. X comma y comma fxy, that is z. Okay, if that is the case now, then on xy plane I have a point called x comma y. For this point, if I go top, it will hit this point. This point, it is x comma y, means this point straight down on xy plane, the point is x comma y, for which if I go up, it will hit this point, and then height is z or fxy. If that is the case, then if I move delta x along x-axis, if I move delta x along x-axis, what is the new height? That is x plus delta x comma y comma fx plus delta x comma y, fx plus delta x comma y, or new z. New z will be there. Okay, or z, if previous was z, then it is z plus delta z. Similarly, from the x comma y, if I move only in y direction delta y, the new point there will be x comma y plus delta y, and then height will be f x comma y plus delta y. Consider the first line from the x y z to new point, that is x plus delta x comma y comma z plus delta z, is one line. Line means vector. There is another vector in that direction. Okay, this vector is surface vector, because if I move along x-axis and then I go and hit top, I hit a new point on the surface, for which the new coordinate is x plus delta x comma y plus f function over x plus delta x and y. So if this is the first point, the next point is in along x-axis, this is the new point. Then if it is the first point, then along y-axis, that is the another point. If I connect these 2 points, this is one vector, this is another vector. Okay. Consider this is very small delta x, so vector will be tangential. This is the new way. I cannot help anything. Someone would say, if this is the new point, this is the new point. If I connect it, it will pierce the sphere rather than tangential. Consider delta x and delta y tends to 0. And since it is algebra, so we are calculating momentarily at that moment. So it should be all right. In that case, one vector is x plus delta x plus delta x minus xi plus yj, y minus yj plus fx plus delta x comma y minus fxy k, one vector. Another vector would be x, another vector would be x minus xi plus y plus delta y minus yj plus fx comma y plus delta y minus fxy k. Now if I do cross product of this will give me, because these are two tangent, surfacial tangent, at that moment it will give the surface area. So surface area will be cross product of delta xi plus fx plus delta x comma y minus fxy k, one vector, minus delta yj plus fx comma y plus delta y minus fxy k. These are the two vectors, vector A and vector B. If I calculate the cross product of these vectors, at that moment, at point x comma y, at that moment it will give me the surface area. Okay, A cross B, where A vector is delta xi plus fx plus delta x comma y minus fxy k, cross B vector is delta yj plus fx comma y plus delta y minus fxy k. Okay, this is the surface area of the sphere at that point x comma y. But if I see closely, delta xi plus fx plus delta x comma y minus fxy k, if I divide it by delta x, if I divide it by delta x, then it becomes plus i plus fx plus delta x comma y minus fxy by delta x k. The second term is nothing but dfxy by dx, as per the first principle of differentiation. It is exactly dfxy by dx. So I plus dfxy by dx k. Similarly, other vector, if I divide by delta y, it becomes j plus fx comma y plus delta y minus fx comma y divided by delta y. It is dfxy by dyk. This is our proof. This is not available anywhere else so neatly. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Now in that fashion, now we have to do If I divide it by delta x and there I divide it by delta y, cross product. If that is the case, the whole is divided by delta x delta y. In return, I have to multiply it by delta x delta y also. Then it becomes I plus dfxy by dx k cross product with j plus dfxy by dy k, and there delta x delta y. Okay, this I plus dfxy by dx k is it exactly same as dp by dx, where p is the position vector of that point. I had taken a point here xyz. If there is a position vector for xyz from the origin, the position vector would be xi plus yj plus zk. dp by dx is nothing but I plus dz by dxk. dp by dy, the position vector by dy is nothing but j by dz by dx k, dz by dy k. Same thing, right? So I can rephrase it as dp by dx cross dp by dy into delta x delta y. Delta x delta y, I can say dx dy. This is the surface area. dp by dx, dp vector by dx cross dp vector by dy dx dy. Now this is the equation of surface area. Now I have to calculate dp by dx cross dp by dy. This will result in a vector form. Get the magnitude of it and then integrate it for the full surface, means x and y, wherever x goes and y goes. Full limit integrate, you get the surface area. Not satisfying, right? We will see that because primitive calculus is more powerful than new calculus. But anyway, what I can do? This is the tendency nowadays. We will talk about primitive calculus also. Let's calculate it. So dp by dx cross dp by dy is giving me dp by dx cross dp by dy and then integration with d. So calculate the magnitude of dp by dx cross dp by dy. What is p? What is dp by dx? P is xi plus yj plus zk. That is I plus dz by dx k cross j plus dz by dy k. If I do cross product it becomes dz, minus dz by dx I minus dz by dy j plus k. Magnitude is dz by dx whole square plus dz by dy whole square plus 1 square root. Now, if I am taking for the sphere, then z equal to a square root of a square minus x square minus y square. This is the equation of the sphere. dz by dx whole square, x square by a square minus x square minus y square. Someone would calculate dz by dy whole square. That is y square divided by a square minus x square minus y square plus 1 square root. It will settle down as a by square root of a square minus x square minus y square dx dy, where x and y limit that we have to set. So x is from minus a to a and y is minus a to a. We will see like this if it works. Okay, so that is the limit that we have to, because this will have impression on the xy plane as a circle. So limit for the x is minus a to a, that is the radius of the sphere. Y is minus a to a, that we will see. Okay, if that is the case, then we will, it is difficult, right? A by a square root of a square minus x square minus y square. Okay, now the actual surface area, if someone calculates it, then it becomes now dx dy. Now let's consider polar coordinate where we will change x, we will take x equal to r cos theta and y equal to r sin theta. Okay, r cos theta and r sin theta x and y in polar coordinate system. Now it becomes a by a square root of a square minus r square cos theta minus r square sin theta. Square root of a square minus r square. A by a square root of a square minus r square. Okay, if that is the case, dx dy, that is dxy plane, can be written as dx dy by d theta dr into d theta dr. Dxy plane by d theta r plane is nothing but, this is the Jacobian that we need to calculate. This is called full-fledged Jacobian. Dxy plane by d theta r plane into d theta r. If that is the case, then dxy by dxy plane by d theta r plane is the Jacobian that someone need to calculate and then d theta dr. What is that? Now, for the Jacobian, someone has to set the matrix for the Jacobian. Okay, where x equal to r cos theta and y equal to r sin theta. For this, I believe Jacobian matrix would be I, J, and K, and then dx by d theta, dx by dr, dy by d theta, dy by dr. Through K, someone has to calculate this determinant. Okay, so this will come as r. This is what I believe. dx by d theta, dx by d theta, that is r cos theta. So it becomes minus r sin theta. Then dx by dr, that will become cos theta. So minus r sin theta, r cos theta. Okay, I am sorry, minus r sin theta and then cos theta. Here dy by d theta, r, okay, y is r sin theta. So r cos theta and there sin theta. If someone calculate minus r sin theta and sin theta minus r minus, okay, minus r sin square theta, okay, and minus r cos square theta, it becomes minus r. So for Jacobian we take only the absolute value r. R is the Jacobian. Okay, if R is the Jacobian, then R d theta dr, and here a by square root of a square minus r square. Now the limit would change. Now theta is 2 pi and r is from 0 to a, that is the radius. This proves that if I am taking like this, the original limit was x was minus a to a, true, but since it was a circle, the region in which we were calculating on xy plane, it was a circle. If x is from minus a to a, then y is from a square root of a square minus x square minus a square root of a square minus x square to plus a square root of a square minus x square. Anyway, it changed it to theta is 2 pi and r is from 0 to a. Someone can get from other also. If y is minus a square root of a square minus r square to plus a square root of a square minus r square, x is minus a to a. If that is the case, then y is, consider y is from 0 to a square root of a square minus x square. Okay, y equal to square root of a square minus x square. This proves that y square plus x square equal to a square. Limit I am converting it to polar. Now x is r cos theta, y is r sin theta. That will come at r square. R square equal to a square. R equal to a. R equal to a. And we tried from 0 to a square root of a square minus x square. I should have tried y as minus a square root of a square minus x square to plus a square root of a square minus x square. So I am calculating half of it. Later we will double it. So in that case, radius would go from 0 to a. Okay, y is 0, then r is 0. Okay, because y is 0 means 0 equal to r sin theta, r is 0. Now if that is the case, then a is from minus a to a, x is from minus a to a. Okay, x equal to r cos theta, y equal to r sin theta. Then y by x equal to tan theta. Theta equal to tan inverse of y by x. Okay, if y is y by x, if tan inverse y by x, now y would be 0 on x-axis. If a is minus a, then it is minus 0. If x is plus a, then it is plus 0. So tan inverse minus 0 and plus 0 will be pi to 0. So 1 is pi to 0 and radius is 0 to a. If I double it, then it will become pi to 2 pi to 0, whatever. Anyway, but if someone talks in polar coordinate system, blindly I can say theta is 0 to 2 pi, radius is 0 to a. Or we can double, radius is 0 to a, and theta is pi to 0. We can double it, it will become same thing. Theta is 0 to 2 pi and radius is 0 to a. And then integration of 1 by square root of a square minus r square r d theta dr. Now someone can calculate it. AR divided by square root of a square minus r square. A I can keep outside. R by square root of a square minus r square integration will be minus square root of a square minus r square, because then differentiation will be same. That is r by square root of a square minus r square. So minus square root of a square minus r square is the integration of the first dr term. R 0 to a, then a will be 0, 0 will be a, okay, minus minus plus a, theta 2 pi, 2 2 pi a, 2 pi a is the net integration. A I had kept outside, 2 pi a square. But since I had started from the Cartesian coordinate system where centered at the origin, top hemisphere, I calculated the surface area. 4 pi a square is the surface area of the sphere. So this is called full-fledged Jacobian. We calculated dxy plane to d. First we calculated the surface area. Surface area is nothing but dp by dx cross dp by dy. Okay, and then this dp by dx cross dp by dy, dp by dx cross dp by dy, it resulted in a by square root of a square minus x square dx dy. Since we cannot calculate this calculus, so we converted dx dy into polar coordinate, and then dx dy by d theta dr, dxy plane by d theta r plane. That Jacobian, full-fledged Jacobian we calculated, and then can you see how much time it took? Calculating the surface area vector in xy coordinate, and then converting into theta r coordinate, then converting the limit also in theta r coordinate. It was very difficult. So the answer lies in cross Jacobian. What is cross Jacobian? This is our invention, cross Jacobian. Just see how much pain we took to calculate the surface area. What we want? We want dp by dx cross dp by dy, right? dp by dx cross dp by dy dx dy, or d surface area by dxy plane into dxy plane. This is what we are trying, right? Okay, then what is cross Jacobian? What is cross Jacobian? Now, cross Jacobian is something. Now we take, okay, probably we'll talk in next session because it will take time. Okay, so cross Jacobian is I have xy plane, on top of it I have surface, that is z. Now if I say x equal to r cos theta and y equal to r sin theta, then I have another plane called theta r plane. As per the method of substitution in integral calculus, we we substitute x with r cos theta, we substitute y with r sin theta to solve our problem. But indirectly, we are entering into other coordinate system, that is polar coordinate system. If this is xy plane, on top of it I have z function over x and y. X function over x and y is dependent upon xy plane. If I say x equal to r cos theta and y equal to r sin theta, this xy plane is dependent upon theta r plane. Z is dependent upon xy plane. When I say function over xy is z, and if I say x equal to r cos theta and y equal to r sin theta, then now x and y is dependent upon theta r. Okay, is there any way that I can take out x completely and make z directly dependent upon theta r? This is cross Jacobian. This is our fundamental. Okay, rather than calculating the full plane and then go for full Jacobian, if z is dependent upon xy plane, z means this z. This z is dependent upon xy plane, and then xy plane is dependent upon theta r plane. Can I make directly this z dependent upon theta r plane rather than first x and y, then x and y to theta r plane? This is cross Jacobian. It will speed up the computation. But how I can move in cross Jacobian? That is the main tedious work. We have, for the calculation of surface area, we have dp by dx cross dp by dy into dx dy. That gives me the surface area. But this computation, when we solved it, it becomes so complex, then we landed up into theta r. If that is the case, can directly from here only can I mix, go directly? Means dp by d theta r into d theta r. Is it possible? dp by dxy plane into dxy plane. Can I go directly dp by d theta r plane into d theta r directly? If I go, then we can solve it very quickly. This is our invention. Okay, that is the innovative approach in calculus. So cross Jacobian where we calculate the surface area in xy plane directly taking independent component through the theta r. That is cross Jacobian. So that we will talk. I believe it is too long. So that we will talk in the probably next session. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.